Hi, Don. Hi, Patrick. Audrey. But I'm hearing an echo. 1 second. Okay, great. So as we wait for guys to join, today I'm behind the Web3 Club's account, and unfortunately, I cannot open my camera today. I promise I have a good reason. So if you can open your camera, as usual, you know the drill, unless you have a really good reason like me one day. So thank you so much for joining on time. We're still holding on, still going strong. And maybe before the rest of the guys join, we can start at about 10 minutes in, just so we, unmute, get to know each other. I know there's some people here who I have never seen or heard, but you guys are constantly reacting, you know. So today, if we can have Karen, I don't know if you're in a position to unmute and just introduce yourself. And if you're bold enough to give us a recap of what you've understood or what you're looking forward to, that would be great. Karen, if Karen is not ready, maybe we can have Jess. Karen, Jess, no, Adrian, George Jr. I'll keep calling names until someone responds. We must have someone. Okay, that's okay, Karen. Thank you for maybe next time we'll catch you at a better place. Um, Siri, Siri E, but find that to be an interesting name. Siri, or anyone. If you're feeling like you want to say hi, just unmute instead of me calling out names. Let's see who unmutes today.
Good evening, everyone.
Thank you, Mohammed. It was getting quiet. How are you doing?
I am good. How are you?
I'm well. Tell us who you are, what you're doing currently, and maybe a little recap of where you're at from this course.
So my name is Mohammed Amin. I'm a student. I'm doing computer science, bachelor's in computer science, and uh, today is actually my second session because I joined in. My first session was on uh, on Tuesday, if I'm not wrong. Yes, on Tuesday. On Tuesday was my first session.
This Tuesday?
But yeah, judo was my first lesson.
Great, great.
But nonetheless, I'm looking forward to understand the use of AI and the AI agents and how they work, and also the different models and tools and agents.
Awesome. Thank you so much, Mohammed, for that. Welcome to the session. You've started, we've already completed the foundations of blockchain, but you can always revisit the recording or the slides. But regardless, next week we're going to get deep into smart contracts. And because the whole purpose of this cohort is to be able to ship faster or to ship faster with AI. So this week, we really want to understand what tool it is that we're using to build. And for those of us who have been here since last week, I promise you'll catch up, Mohammed. We already learned that smart contracts are kind of, you can program smart contracts to do whatever you want, right? Like, I think how I'd interpret it is very robotic. And then you have AI agents which allow you to create or to add more context. Like, for example, anyone I know currently has already tried to make a trading bot, which can detect the price of something and then you can connect your wallet address and then it makes the trades for you. That's kind of how I'm seeing the application mostly. But I think there are so many angles we can look at how we can use AI with smart contracts. So if you're confused, that's the journey we are trying to understand all the way to,
Mm.
like, is there something, like, for example, is there a way you can have an agent sensing, the temperature of something and then allowing something to happen? What kind of problems can we solve with that kind of technology? So yeah, so that has been
And I'm
my,
looking.
yeah. So I don't know if someone else has something to say. Karibu Sana Mohammed. Anyone else before we start in like a minute so that Don can introduce the session?
Thank you so much.
Anyone else can just unmute and go.
Hello, guys.
Hi, Sairi. Please tell us how to pronounce your name while we're here. Siri?
Yeah, Siri. That's how you
Ah,
pronounce it. Yeah.
nice.
So, guys, I'm glad to be a part of this cohort. I've been here. I think this is I don't know if I think the fifth lesson or fourth lesson. I'm a creative innovator and very much interested in getting to know how I can be able to use the tech bit to enhance my skills and provide solutions for creatives. Um, yeah, like the things we've been taken through, like the subjects and the things we've been taken through, I was able to follow through, like the blockchain, the AI fundamentals, and now what you're about to dive into, which is agents, AI agents. So I'm just eager to learn and understand more about what you're trying to do. Yeah, I must admit, like, I'm not conversant with so much because I'm not like from the technical part of what you guys are doing, but I'm just open to getting to understand what all of this is about and how I can use it to be able to create digital solutions. As my name is Siri, or Siri, named after the AI assistant, so it's also very strategic. Yes, I think that's what I'd say.
Nice. I love
Okay.
that. And we love having creatives around, if you've noticed from our past doings. We had a collaboration at Homeboys the last, I think, 2 weeks ago. And we are also trying to understand how we can collaborate with different industry experts who can,
Yeah.
add more context to the solutions that we are trying to create. Because and it's an interesting topic, because someone said with all this AI we have so many pieces of software, but we still have the same problems.
Yeah.
Healthcare is still in the pits, our artists are
Mhm.
still pretty much underpaid. So how
Yeah.
exactly, do we make or create value? So now it's a very interesting topic for the software engineers here. I truly believe that I don't think AI per se is gonna replace software engineers, but it's creating a new skill set. And right now, I'm feeling the spirit is telling me that the skill set is heading towards AI agents, like being able to actually automate workflows. If you can equip yourself with
Mm.
that kind of knowledge, you'll be pretty much sorted. So I'd like to welcome Dawn to introduce the session today, and
Kesi kamera alafu unmuted. Tiandi.
Dagi, you can talk to us as well. But Dawn,
Yeah, yeah, I think I can get started with today's session. Thank you all for being here. Yeah, so I'm just gonna get started by sharing my screen. Just give me a second, and then we can go all in. Okay, I hope you guys can see my screen.
yes, we can see it.
Awesome. Okay. Okay. So again, so in the last session, we were kind of covering the core fundamentals of models and all the terminology around models. So that was meant to give you a solid foundation for this next topic about agents and tools. One thing I would want to say is, so we're still covering fundamentals here. More exciting stuff awaits in lesson 3. But still, with this session, our main focus is going to be on covering the fundamentals of trying to make it such that everything is understandable to even people who are less technical. Yeah, so, and also you're free to ask questions along the way in case you don't understand any of the stuff that they cover. Right, so yeah, today's lesson's about agents and tools. So agents are kind of wrappers that get built on top of the models we had covered in our last session. So let's just dive into it. Yeah, so starting off picking up from where we left off. Well, starting with what the model is. So the model is just the brain, and on its own, it can't do much. It can't control stuff. It can't write code, run code, write to files, run those files. So there's need for a wrap around the model in order to get it to achieve all like the complex stuff that you may want it to achieve. So today we're gonna start from the basics. Where the most fundamental concept to understand is what functions are. So that's what we're gonna start covering. So what functions are. So before we go on to talk about what tools are and how agents operate, the first things we need to understand is what functions are. And this is just made so that everyone can understand. So a function is simply just a piece of work, and it's just gonna take in some inputs. These inputs parameters. If you're from the software world, these are just parameters it takes in, and then it does some work. And once it's done with that work, it spits out some output, which is a result. So here we have an example function, which is brew coffee, taking in the size of the coffee, like large, medium, small, the number of shots, 2, 3, the kind of milk, cow, almond, whatever else. And then the output is the cup of coffee. So the name says what it does, so brew coffee, and then the parameters shape exactly what comes out of it. So here we have like a model of a function you can interact with, just to show you like non-technical folks how functions usually work. So we have defined a function brew coffee, and then it takes in these different parameters: size, number of shots, and milk. And then the output in this case is like what the price of that coffee is. So if I choose a small coffee, a single shot with like oat milk, the price is like $3.50. If I choose 3 shots, the result changes, right? So yeah, that's simply how a function works. Functions are the most fundamental concept you need to understand when working with agents. And once you understand functions, you can now understand tools. So a tool is simply just a function, and it's a function which is handed over to the large language model, or simply the model, with a description of what it does so that the model can understand how to use that function. So basically the function plus a description the model can read. So an example is, let's say, get weather function. So that gets put as like the tool name, get weather, then a description of what that function achieves. So that description is like get the current weather, and then the parameters, which is like the city where you want to get the weather from. And another example here is send email. So you have a function called send email. It has a description that accompanies it, and then parameters like to, subject, body. So just imagine as you open up in Gmail and you want to compose an email, right? What you text in, those are the parameters. There's a to, subject, and the body of the email. So yeah, that's how tools basically function. So it's just a composition of the function plus the description. Okay, so the agent basically forms a wrapper around the model. So the model only handles prediction of text. So when constructing an agent, the things or the ingredients you put into that construction of an agent is you have the model, which is, let's say, the main ingredient, and then you have the system prompt, which we covered last time, which is just a let's say like prime directive, if you watch Star Trek, like a prime like instructions that the model should follow when interacting in that environment. So you have the system prompt, and then you have a list of tools. So like a tool menu. So just imagine a list of all something similar, very similar to this, right? Get weather description. So like a tool menu, and then the agent loop. So we're gonna cover the agent loop in one of the next slides. So an agent is just a composition of the model, system prompt, and then the tools, and then the agent loop. And the way it works is the model will predict text, and that text is usually it making a decision on which tool it should call in order to complete a task. So there's a simulation we can go ahead and look at. Next slide. Right. So this is, let's say, a simulation of an agent that's basically a travel assistant, and it has 4 tools. It has, the first tool is search for flights. The second is create a calendar event. The third is get weather. The fourth is send an email. So basically, a user prompt would be, let's step 1. So user says, find me a cheap flight to Mombasa next Friday and put it on my calendar, right? So that's the user prompt that's coming in to the model. And then the model will take that in and then predict text that will handle, that will make a decision on like which tools is it gonna call in order to fulfill the incoming user's request. So the model will take in, and this is like, let's say, a simulation of maybe what the model would be thinking about. So I need flight options first. I'll call a tool, and then it sees the menu of tools that it has access to, and then it's gonna call one of them. So I'll call a tool. So this result is it outputs its result, which is basically a list of the tool itself and the parameters that you need to pass in to the tool. And then the agent itself will handle the actual calling. So next step, or the actual tool call. So texting the results, then the tool call, the tool call is made. In this case, you're calling search for flights. We'll be passing the destination, which is Mombasa, and then the date, which is next Friday. And then this tool call will have a bunch of tool results. So the tool results, which is we have 3 flights, and there is the cheapest one at 8K, departing at 9:15 on Friday. So that's now tools themselves can have access to like real data from the world. So in this case, such flights is actually calling like some let's say Kenya Airways API and getting all of this data. And once we get those tool results, we then feed it back into the model. And then the model now has knowledge of what flights are available, how much do they each cost, and then can make a decision to call the next tool in the chain. So good, now schedule it, another tool call. So it needs to now schedule the calendar event. So it's gonna make a tool call to the create calendar event, passes in the parameters, that's the title, the time, and then the tool result will come back saying the event was successfully created. Right. And then once it's done, it's just gonna say booked ready. So this is the final text answer that is gonna show to the user. So just saying, I've already booked it for 8K for Friday, and added it to your calendar along with those details. So two things to notice from this example. The first one is the agent had 4 tools, but it only made use of 2 based off what the user had requested. So yeah, agents basically make decisions on, you basically provide agents with a bunch of tools, and then based on of that, they can make decisions on which of them is most appropriate to fulfill the incoming user's task. The second one is the agent will usually continue to call itself until the user's request is fulfilled. So in this case, you notice the user didn't have to tell it to continue like after it got the tool result here. So agents are built in a way that they can ensure that the model continues until it's done with the task that it's been given. So that's done using something we'll cover in the next slide, which is agent loops. Yeah, but those are kind of the 2 important things to take from this simulation. Yeah.
Don, before we continue,
Mhm.
could you kindly explain to someone who is interacting with all these terms for the first time, like what a tool call is, and
Yeah.
maybe a visual journey, like a visual journey of what a model is, what a tool call is, and
Mhm.
maybe just from there first. Let's see.
Okay, so I guess it goes back to when I introduced functions. So a function is basically a piece of work. So tool calls are just functions. So a tool call is basically a piece of work. It takes in inputs, it does a certain work, and then it returns a result, which is the tool call result. So let's go to a simulation. A simulation here, the tool call is just the function being called. So we have the function search flights. It's taking in those parameters like the destination, the date, and then it does some work and it returns the tool result. Right? And then that tool result is fed back to the model. Now, the model itself, which we've covered in lesson 1. So models, or generally in our case, what we are dealing with is large language models. Basically models which can predict next predict text, right? And the way the predict text is usually useful for, or is just useful. So a model is just something like, I guess in simpler terms, what you've interacted with when using ChatGPT. When you go to chatgpt.com, what you interact with there, that's a model behind the scenes. Yeah, I'm not sure how detailed you wanted me to go with the description. I hope that answers.
It's heading there, because I'm also trying to wrap my head around, what point you stop, just plain relying on ChatGPT and what makes it an agent, so would a tool call be, let's say, an API call to, I don't know, CoinGecko or Notion, and then that information is fed into the model, and then, something of that sort. That's what I was trying to wrap my head around. But if anyone has a question, you can.
So I think with what you've asked, right? So some of it is, I guess, kind of the reason why we need to kind of cover the fundamentals first, right? So when we define these functions and you're saying it's doing some work here, where we say it does one job, or the work as of I'll put it there. That could be anything. It could be calling the CoinGecko API. It could be doing something on your Notion. Anything that can be done programmatically fits into this box called the work. So yeah, tools themselves are just functions, a combination of the function and just a description of what the function does, as we covered here. Yeah. So just a combination of the function, description, and then that gets kind of fed into the model so that it can now, based on a user's requests, it can make a decision of what should it do in order to help the user achieve like whatever goal they've set out. Yeah.
Awesome. Thank you.
Okay. Any questions? Let's see. Nothing in chat. Okay. Okay, so I'm gonna skip over these. Let me just skip over that. So the next like foundational concept. So we have covered functions and how we compose functions into tools, and how like agents are basically wrappers around models. And you've seen a simulation of how an agent interaction works, right? So now the core driving unit of or the core driving unit of agents are the loops. So I think for the non-technical people, it's important we also cover this, just like a brief overview of what loops are. So loops are just basically like just telling a computer to repeat doing something until a specific condition is met. So repeat doing X until a certain condition is met. So I guess a simpler example is when you're cooking ukipika uji, you have to keep stirring until it's done, or like ready for you to kuikunywa. So yeah, so that's basically what a loop is. Just keep on doing something until a certain condition is met. So yeah, just a brief overview. I guess if you have any questions at this point, you could just ask them now. Then we can proceed to how loops are now coming as in agents functionality. Okay. Yeah. So I guess probably you'll have a few questions later. But I hope you've understood like this concept as well. So since we've covered loops, now I can introduce the agent loop. So the agent loop is kind of what makes the magic that was happening when the agent was calling all those tools for like search for the flights and then creates a calendar event. This is the core piece of functionality that was making that happen. So here we're just gonna cover composing, just composing all the different pieces we have built over the last two lessons. Yeah. So here we have an example agent loop. Okay, this is an example agent, right? And it's gonna take us through the process of constructing all the different pieces. So the first part of an agent is going to be the system prompt plus the tool menu plus let's stick with the system prompt plus the tool menu, right? So then yeah, so and then all of that wraps around the model itself, and then users queries will now execute around the agent loop itself, where you're constantly asking the model to make decisions based on the input or the goal that you've given it, and then it comes up with its answer. Yeah, and then that just shows up as the final answer. So here it's just gonna take us through how we assemble things. So we first assemble the context. So that's the question, the tool menu, the system prompts, but the agent itself has no idea, or we don't pre-fill stuff about the car, like today's weather, stuff like that. And then next, the model reads the user's request, and then it makes a decision. It says, since it doesn't know today's weather, it should maybe call the get weather tool, so they can get an answer for what today's weather is. So the model makes a decision on that action, and then it runs the get weather tool for Nairobi, gets the current weather, and then adds that as like a synthetic message or synthetic prompt, as we had covered in the last lesson. So add this as a synthetic prompt to the context window, and then basically does this loop again. So you're gonna assemble all the contexts, synthetic prompt included, and then pass it through the model. So the model now reads with enriched context. So it now has context of what the current weather is, and it has everything it needs, so that it won't make a decision now to create a new tool call, because it already has everything it needs to answer the user, right? And since it has everything it needs, it just output like the final answer. So what should I wear in Nairobi today? And then you'll output the final answer saying, since there's light rain, carry an umbrella, and then like that kind of terminates like the agent loop and just gives you an answer. Yeah. Okay, so any questions here? Yeah.
Guys, as usual, don't be shy. If you need a clarification, feel free to unmute. I think we have a hand raised. You can go ahead and unmute, Ashley.
So my question is, yesterday we said models think through predicting tokens. They don't think like humans. But with agents, they are making decisions like humans. So like, how does that work out?
Yeah. So what agents do is they only introduce the ability for these models to take control of things and do work. So that's by calling like these tools, they can do some work. So in the last lesson, what I said was there's AI doesn't really think. It's just outputting like its best guess of what the next output tokens are gonna be. And for the most part, that's usually right. Like, so we kind of build around the fact that we expect what it predicts to come as the output to be the desired like decision for it to make. So all the models have been trained such that the way those predictions come out, they kind of meet the expected or desired outcome. Yeah, so we kind of just call it thinking, for lack of a better term, and build agents on top of like that ability of the models to do the thinking or just do the best guess, like next token prediction. Yeah, so it's not thinking the same way we do. It's more predictive, like predictions based on like probabilities to make the best guess. And I guess there's it seems to work for the most part, or it seems to be working for the most part. Yeah. Does that answer your question? Any additional clarifications you need? Okay. I don't know what silence means. So I'm just gonna go ahead and continue. Yeah. So but please, like, if you still have, pardon?
Oh, I think it's all good for now.
Okay.
I think, I don't know, Ashley.
Yeah. That makes sense.
Okay, yeah. So we've gone through this simulation to understand how the agent works. So yeah, this is just a description of that process. So the loop just means it keeps going while the model keeps returning tool calls. So as long as there's a tool call result in the model output, the agent loop will continue running, and it only terminates when there's no tool called result or when there's just a plain text answer. Like in our case, it was light rain, 19 degrees Celsius, grab a jacket and an umbrella. So that was kind of the final model output that didn't include like a tool called result. Yeah. So that's kind of the termination condition. Again, just back to the loop thing we had discussed earlier. Yeah, but we also need like additional controls around how these agents are able to run. So in some cases, the tools you give the agent access to may be, let's say, have access to something like, or have the ability to, let's say, delete your home directory on your computer. So something like that. So in order to, since all of this is done like probabilistically and predictively, there's no way of knowing what tool the agent will end up at or what arguments it will pass into the tool. So you could imagine that for, let's say, more complex tools. Here we're just covering something like get weather and what else? Brew coffee, get weather, right? A lot of harmless functions. But in the case where it's a function which may have the ability to, let's say, nuke somebody's home directory, you need to add additional like guardrails to prevent it from happening, or like prevent it from doing something wrong. So in addition to the way you add that, there's like max iterations where you say the agent can only go through its agent loop X number of times. So that could be the agent can only go through its agent loop 10 times, or time limits, where the agent can't go through these iterations for more than an hour, or even cost caps, because each iteration of the loop involves sending data and expecting data back, expecting output back from the agent, which is like running inference, and inference is usually really expensive. So you may also have some like cost limits you're trying to have the agent keep track of. And yeah, so a lot of these safety guardrails and all that stuff I've just described right now is part of a harness. So think of a harness as a wrapper around an agent or a number of agents. We'll cover more on how harnesses work a little later on. Yeah. Let's see. Yeah. So another fundamental concept to introduce here is the fact that especially with harnesses, so harnesses are like wrappers around agents. So you have a harness like Cloud Code, Casa. I mean, I'm not sure which ones you guys have interacted with, but Cloud Code, Casa, like even ChatGPT itself, right? Like as you're chatting with ChatGPT is basically like the site is like a front end for an agent. So it can also do agentic tasks in the background. So all of those are just you have the agent, and then there's the harness on top of it, which will be enforcing like guardrails or providing specific access, specific access, or having the agents run in specific environments. So these environments can include like running within the terminal on your computer or running in the browser, or yeah. So that's kind of a brief introduction to harnesses. But essentially, what a lot of harnesses do is, in order to enforce some of these guardrails and also in order to drive how agents act on the tasks you've given to them, they usually feed additional synthetic prompts. Okay, so for those who aren't in the last class, synthetic prompts are basically prompts which weren't written by the user, but get input into the model's context as like a user message. And so harnesses will basically feed these synthetic prompts to kind of guide the agents in like a specific way based on like what the harness developer intentioned for the agent to be able to do. So you'll see this for things like skills. I'm not sure how many of you are familiar with skills with the agentic. Okay, if you've been using agentic tools, there are some things called skills, which are basically a bunch of text which tell the agent how to do a specific task. So yeah, so that's usually just injected as a synthetic prompt into the model's context window so that it knows how best to answer users' question. Yeah, so yeah. I guess this slide just goes over what I've just discussed. You have skills, you have hooks, and even some instructions around compaction, as well as even so compaction as well is usually, or it's a concept in relation to agents, not the model necessarily. So as the agent runs, let me go back to the demo. Where is it? This one. Yeah. So as the agent runs in this loop, so remember we had earlier on in the first lesson covered context windows and how context windows basically grow over time as new user messages get added into the context. Yeah, that's just user prompts to the model gets added. So compaction is a feature of agents whereby they'll detect when the context window is almost running out. And when they detect something like, let's say, the context window at the moment is like at 80%, or I don't know, mostly it's like 80%, they'll kind of trigger compaction, which is basically sending back to the model a synthetic prompt that says, you need to summarize this entire conversation and summarize it into something like what have we achieved, what has the user achieved in this conversation, what's still pending, things like that. So that and then that compaction summary that gets returned as the model result then gets attached to the next context window as like a synthetic prompt. That's like the first message. And then that just happens kind of in a loop. So yeah, compaction. There's compaction, hooks, and scales. So yeah, any questions at this point?
Okay, I have a question.
Yeah.
So are embeddings calculated similar to how models tokenization is calculated?
So your embeddings is a different context. Concept. So models are like, okay. His question kind of requires me to explain in more detail. So apologies if anyone else is lost. But so models are just like neural networks, right? And these neural networks only take in numbers as input. So vectors, basically like vectors of numbers as the input to these models. They process them and then they come out with vectors of the output. So but you as a user, right, when you're interacting with ChatGPT, what do you put into the model? You don't put numbers and vectors, you put in text, right? So embeddings are basically the result of converting the text or the prompts into a bunch of vectors, and then vectors of numbers, right? And then these numbers get fed into the neural network, and the neural network will now come out with like results vectors, and then these results get converted back into text. So that's what embeddings are. Okay, so back to your question regarding I guess it's kind of about how tokens are related to embeddings. So the size of these embeddings it's calculated in tokens, right? So that's how all those different terms fit together. So now, if you could repeat your question again.
Oh, okay. So previously I've worked with embeddings such as the LangChain and
Yeah.
stuff. So
Yeah.
it was working in a different way, whereby it was converting PDF files into small vector stores. So I was quite curious because there was a time I had depleted all those embeddings free trial. And so I was quite curious to know, are the tokens really related with counting?
Yes.
How they're calculated? Are they related with the embeddings?
Yeah. So in your case, just to clarify, the PDF was first converted to text, and then that text was now converted to the embeddings. So embeddings also, in order to generate these embeddings, in that case, it's in order to generate basically these vectors, which you end up storing in whatever vector database you're using, it takes computation. There's like cost to doing that conversion. So that's probably what you maybe overuse that. Yeah.
Okay, thanks.
Yeah. All right. Any more questions? Let me check the chat. No questions in chat. So are we good? Going one, going twice. Okay, so let's continue to the next one. So the harness. So you're being kind of talking about what the harness looks like. So it's just an additional wrapper layer around now the agent. So we started with the model, and then the agent and all the concepts I discussed beforehand just wrap around the model, and then the harness now wraps around the agent and is basically providing guardrails and more specific specifications about what specifically needs to be achieved by the agent when it's doing in order to do a certain task. So yeah, harness wraps around the agent with guardrails and additional plumbing. So it will handle stuff like permissions, handles maintenance of the loop, the agent loop we discussed before, retries, max iterations. It also guards against prompt injection. Yeah, I think earlier on we had discussed prompt injection. So this is kind of where some of the security concerns, some of the security things get caught or prevented from happening, and runway costs. So yeah, also handles logging, observability, human in the loop approval. So that's kind of, think of a harness like when you're interacting with. Okay, so I'm not sure what coding agents you guys have interacted with, but whichever it is, if it's open code, if it's Pi, if it's cloud code, those are basically harnesses. They provide logging, observability, the human in the loop approvals. Yeah, so this is a new term, human in the loop. So human in the loop basically refers to giving humans the ability to, let's say, steer the process through which the agent achieves its like a task or goal. So this happens by providing humans with a way to like providing a feedback loop between the agent and the human. So this is usually through like approval models. So if you have used any coding agent, if you don't like set it to dangerously skip permissions like me, you usually prompted with like these approval models which ask you, do you actually want this to proceed, or yeah, do you want to stop this from happening? So yeah, so those are some of the pieces that the harness now provides as just the second layer of like wrapping around the agent. I mean the model. Yeah. So I saw a question being posted here. Let's see. What runway cost? Okay, so tokens are usually priced per million. So you have like let's say something like Opus. Opus is like $20 per million tokens. Now the thing is, usually you blow through if you're using an agent, like a coding agent, you'll blow through 1 million tokens in like 10 iterations of like the agent loop, right? So usually, I guess unless you're a token billionaire, right? You usually wanna keep costs low, or not have a situation whereby the agent just ends up using like $1 million worth of tokens. So that's what runaway cost is, when the agent, if you just leave it and then it just ends up consuming a ton of tokens, since everything is built in terms of tokens, consumes a ton of tokens, and you essentially end up with like a bill of like $1 million. Yeah, so that's kind of what a runaway cost is. Is it runaway or runway? It's runaway. Okay. So any other questions? Okay.
Yeah, I have a
Yeah.
question, Don, or maybe not even a question, but these harnesses fail sometimes,
Mhm.
right?
Yeah.
Are there, like what's your experience in making a foolproof harness? Because it can actually affect things when, it's easy to mess with permissions and all of that, especially when you run or when you're using agents for databases. We've had those stories. So I'm just wondering how you've observed that area specifically.
Yeah. So I've also had of those stories. Personally, I haven't had like an agent kind of do something like really dumb to that point where it like nukes my entire home directory. But initially, actually, when I was like testing out anti-gravity, when it was just released, I had stories of like people where they were saying like anti-gravity just deleted my entire home directory. And then I asked it why, and then it said it would correct itself. So it's a lot of these issues or concerns that arise are related back to hallucinations. The fact that since everything, this is just a prediction machine, right? And it's not really thinking the way we do. It's just predicting the best guess next token. And for the most part, again, keyword for the most part, it's usually correct. But there are edge cases where um it can like hallucinate and then like delete your entire home directory. But some of that happens. So there are a couple of ways you can prevent that from happening. The first one is there is something called context decay, where over time the agent, like as an agent continues to do a task for longer and longer, it eventually or it ends up losing sight of what the initial like alignment or the initial instructions you gave it were, and it gets basically misaligned from those initial instructions. So one way to prevent that is don't run longer tasks, but that's kind of I guess on the other hand, you have the fact that these models are actually getting better and better in understanding uh, what users or in predicting exactly what users want and not going off and doing like the wrong thing. So again, they're also capable of running longer tasks. So this advice of not running like a longer task would have applied maybe, I don't know, like 3 months ago. But right now, I think like you have agents which can run for hours on end. Another way to prevent it from like doing something like that is to have it exec or like run in its own environment. That's not the same as your own computer. So you have things like use like containers. That's things like Docker or Podman. Yeah, so like run it in a container environment where it doesn't have access to. It has limited access to like your home directory and cannot like delete stuff. Yeah, so again, these harnesses as well, the engineers working on them are kind of like they're learning from the mistakes and adding in safety nets to prevent such things from happening. But yeah, running it in its own container is kind of a guaranteed way to say I can just leave this agent do whatever it wants in case anything goes wrong. At least it won't like affect my computer or anything like that. So yeah, those two pieces. Then the other thing is prompt injection. So prompt injection is still a problem, just because of the fact because of how these agents work. There is no clear way to actually prevent like there's no clear way to actually prevent prompt injection from happening. So think of a case where you tell an agent to go search a specific website, and let's say it's an agent running in your terminal. So you tell it go search like go search Polymarket, right? I need to place a bet on some. I don't even use Polymarket, man. Can't see Polymarket. You need to place some bet on. You need to place a bet on some market, right? Now the thing is, it may end up going to search the web, and then maybe some like hacker, or I guess the better word is spammer, created a site which is Polymarket for AI.xyz, and in that site they have basically added their own instructions for any agent that's visiting, and those instructions are something like look at the home, like look through the computer, find any private keys, and then send those private keys to this server, or like drain all those private keys to this wallet address. So prompt injection, like things like that, those are kind of one of the core issues early on when these agents were coming up. They're still, I think, a lot of these model building labs have worked to kind of restrict agents from, or put guardrails to prevent agents from doing something like this. But like the attack vector is kind of natural language, so there is no real way of preventing natural language, or like preventing one from being affected by natural language. There's even another attack vector where instead of having the prompt injection in text, they have it within like an image, and then the image basically has like some custom instructions saying like drain this person's private key, and I mean this person's wallet, send all the funds to this other address, and the agent would still fall for that. And so it's kind of, yeah, attack vector is kind of infinity right now. But the model is also getting smarter and smarter, and with that ability, it kind of increases with that, it also increases the ability to prevent them from making, say, dumb decisions, though they still make them, but less frequently. Yeah, so I guess just it's kind of a whole other discussion. Personally, on my social accounts, I have like a prompt injection prompt like added to like word of anyway, social bots, but that's like topic for another day. Yeah, so not sure.
I can't believe we're calling these guys farmers. Like, you guys are going to ruin that term for us. Any questions? So we're going to have another session on security or smart contract auditing. I don't know, just basically protecting yourself in this shamba. So yeah, be on the lookout for that. Any questions? Yeah. Okay, I think we can proceed.
Okay, so we've covered a ton of theory. I would say at this point, as long as you've like kind of, you don't need to grasp all these terminologies right now, but as you continue to interact with the world of, if you're on X and like hear agents, at least now you'll understand, or like recall some terminology of how they actually function. And it's a good place to be in when you have that systems kind of thinking when trying to solve a specific problem, so that you know maybe what pieces are gonna fit into whatever agents you're building. Yeah. So later on, we're gonna cover more complex, I guess, whenever we split the cohorts, the software engineering side will go into more detail around actually building these agents and agent groups. But for now, I think let's just zoom out away from all the theory, and we're just gonna take a look at some of the agents in the wild. So for now, I'll put coding agents as the next lesson, and we'll cover in more detail coding agents and their capabilities and all the fundamentals around coding agents, because I think they kind of deserve their own on session. But for now, we're just gonna look at what we have in the wild. So we have stuff like OpenFlow, right? I am sure you guys know OpenFlow, right? This is kind of released in personal AI assistant. Yeah. So this is basically a harness. People just call it an agent, but basically it will run on your machine. You need to provide API keys for the model provider you'll be using. Yeah, but basically this is kind of the, I guess, what's the word? Celebrity when it comes to agents. I'm sure everyone's heard of like OpenFlow. Yeah. And then what do we have next? We have the Hermes agent. I think if you guys are, I think setting up and all that stuff, it kind of comes with its own nuance attached to it. So I think that's kind of maybe a separate session. So for now, I'll just introduce them. I'll show you the sites so you can see, maybe start interacting with some of them. Some of them are a lot easier to use than others. OpenFlow, you have to set it up on your machine, but the others, you can just go to their website and start using them. Next, we have Hermes, the Hermes agent. Let's see, Hermes agent. It's kind of similar to OpenFlow, but a couple of people saying it's a lot better to use. Guess it's you'll kind of need to test them out on your own use case and then figure out which one works better for you. So Hermes agent, OpenFlow, then we have Co-founder. Now this is some of the agents that I love, where it's built to be easy to use. So you don't need to like spin up something on your machine. You can just go to the website and it's gonna set up all your agents for you, and you can just start making use of it. So this one's for like I guess for the non-technical folks. So this is like an agent orchestration tool for handling your new company. At least that's how they tell it as. So it will handle everything from setting up a website for you to just read through this. Setting up a website, setting up socials, engineering, support, emails, even just registering the domain, all those pieces, and just runs everything for you. Yeah, really, really cool tool. Next is we founder. Let's cover Notion. Oh no, let's cover Proxima. Let me sign out. So Proxima is still in early access, so you can join the waitlist, and once it's ready, you guys can test out some of the agents I've been building. So this helps you, like, you can define like a team of agents, or in this case we call them droids, that you can use for whatever use cases you have, and then just connect them to all the tools you use from your email, calendar, Discord, Telegram, Notion, a bunch of other stuff. Yeah. So yeah, there's Proxima, and then there's Notion. Yeah. So I think I'm not sure what if you guys actually use Notion, but Notion does provide agents. So in your Notion workspace, you can actually create like an agent and have it and just interact with that agent. I think the marketing team does a better job of explaining how, but like I think this is kind of, if to get the ground running, it's like free. All the agents are like free. So you can go there, like create agents, have them interact with your Notion. You can put your notes, your projects, everything like in the same workspace, and then make use of Notion's agents to interact with them. Right. Yeah, so those are kind of the highlights, I guess. As I said in the last lesson, and also beginning of today's, the reality is a lot of those tools keep changing, and this list is gonna change like I don't know, like in 1 month's time, something else is gonna show up here. Maybe something you've built. Yeah. So it's important you understand all of these agent tools, all these harnesses, they essentially use all the foundational primitives you just discussed. So yeah, that's why it was important you guys understood all those pieces. And I guess some things I've left out, like the coding agents, which we'll cover in the next session, but just as a mention, there's like Casa, there's anti-gravity, and Cloud Code. Right. Yeah, and also Codex. Yeah. So these as well, they all use the same foundational concepts to function. Yeah. So I don't know what that means. Yeah. So next, let's go to So just go try out these agents if you haven't already. See what they can do. Yeah. I guess that's a homework. Last. Yeah.
Sorry,
Questions.
there's a question. There are actually two questions in the chat.
Yeah.
So Will is asking, are there resources you'd recommend where someone would learn about incorporating agents in someone's workflow? Things like skills and all. So I think this is on the resources side.
Okay. So the way this will work is you're gonna choose your agents, kind of like a game. You choose your agents, and then that's kind of the one you're gonna start using. And each of as a part of a lot of this being experimental, like some of them have different names for the same thing, or like since some things are like super new. But what I would recommend for like a non-technical person, go with Notion. So just go to Notion, because here you can do everything from defining your projects to even creating your agents. I think, as I said earlier, like Notion's marketing team has better videos explaining exactly how to use Notion agents like effectively. But if you're just non-technical, you just want to see how do I start out, just go to search Notion agents, Notion agents on YouTube, see what pops up, and kind of start using them. But yeah, Notion agents is what I recommend for non-technical. For technical guys, depends. So also, just I hadn't answered the complete question. Recommendations about your workflows. So after you've chosen your tool of choice, now, as I said earlier, like it's all experimental. I'm not gonna say I can only speak to like coding agents, which we should discuss kind of in the next lesson. But for the most part, it kind of depends on what exactly your workflow is. Because workflows differ, and I may suggest something that's not as useful to your workflow or whatever work you're trying to get done. But something like Notion, you can basically brain dump everything from your to-dos to the projects to your email to meetings, whatever, and it can like make use of all the tools Notion already provides. Yeah, for coding agents, however, there are specific approaches to ensuring you're using them effectively. But again, I think that's kind of its own its own thing, which I can explain in more detail in the next session. Yeah.
Okay, so I'm assuming you also answered, or rather, Will was asking which agent you'd recommend in terms of productivity without factoring things like complexity of installation. You've mentioned Notion, so I don't know if we're gonna discuss more about it tomorrow, or do you have like a
Okay, so seems like
yeah.
there's psych to discuss Notion. So yeah, I think we'll go through Notion tomorrow as well. Yeah.
Okay, great. Any more questions for Don?
Okay. Assuming no. So but as a start, I think this isn't like how they say like school. It is kind of, but for the most part, you can actually just go and try out Notion agents and see how they how to use them. Yeah, but I guess we'll cover them as well. Okay. So next piece. So in the last lesson, let's see, people. Okay. So for the questions about technical people, then for technical people, next lesson, more in depth around coding agents, skills, ways to use skills, create skills, do whatever. Yeah. So we'll get to that. Yeah. So in the last lesson, right, we had introduced the law around AI in general, right? So I'm not sure which teams you people chose to fight for. Um, any answers? Any doomers?
Could you ask the question again, Don? For
No. So in the
yeah.
last lesson, we had kind of introduced some of the law around the agents, right? There was the Dumas. This is just kind of separate to the theory and everything. It's just about like I guess memes and things we see happening on socials. So like the different categories of people within, or the different trends of thought within the AI industry, where we had like the doomers, we had the optimists, the pragmatists, and then non-believers. So I was just asking like, where do you guys fall? Getting some
Feel
answers.
free to unmute. Yeah. Irene, pragmatist. Jeremy, optimistic. You feel free to unmute and defend your position as well.
Okay, I'm going to say pragmatist because I don't think AI is going anywhere. You know, like in Zakwa, you would rather accept it. When you have radical acceptance, you start making use of the tools that you have, and maybe you can even see the way forward. But as much as I don't think AI is going anywhere, I'm still not buying that it will replace everything and everyone. People will try, but there's a probability that they'll find out it's not completely valid to do that. You can't really replace the magnificent, imperfect humanity, you know? So, yeah, I think because of that, it makes me just want to know how do we approach how do we, with radical acceptance, still approach what the world is becoming? I'm thinking about it even if you think as a software engineer. I can imagine what the people were thinking when high-level languages were coming out. Yeah, walikuwa wanafikiria, oh my god, tumetoka from zeros and ones, and that's like that was, oh my god, everyone is going to know how to do this thing. But no, that's just not the reality. And they keep that layer just keeps building. It feels like AI is just the next layer, because now we are just still ideally engineering, still doing the jobs that we usually do. We just have this extra layer of abstraction, just the way we've been having layers of abstraction from place yenye tulitoka ones and zeros to low level languages, high level languages, you know. So just accepting that maybe it's a layer, it's not going anywhere. So how do we use it? And yeah, what does engineering look like now with this? It's kind of like learning a language. It just happens that the language feels easy because it's it's the language we used to speak. But the things about building a good system, those things still remain. So that's my perspective.
Nice, nice.
Yeah.
Personally, Jeremy, go ahead. Go ahead.
As for me, I mentioned optimistic because generally I feel things will turn out well. Because currently, with the help of AI, you have the courage to tackle even complex topics. You can simplify it and understand it easier. I think because I remember the last time we used ChatGPT, so it's a bit sluggish and dumber. But now, what it can do, it's amazing. So our hope is just believing that the trajectory we are going higher. We are never going back. Yep.
For me personally, I kind of cycle through all the different phases, like every month or like even sometimes on a weekly basis. Yeah, but yeah, just important to I don't know, just something light to talk about. So I'm gonna introduce some new law. So there's two terms based on agency.
We've
We've been
lost
discussing
Dawn,
agency.
or
Pardon?
oh, okay.
Did I miss the question?
I think it's my network.
Okay.
It might be my
Yeah.
network. Yeah.
Okay. Yeah. So we have been discussing about agents. So I'm introducing some new law. So we have agency. So yeah, we have, if we get these machines which can do everything, if you're from the optimist and like AI accelerationist, what's the word? What's the word? Side of things, right? So out of that, you have two kinds of people. They're either NPCs or high agency people. And NPCs, no shade to NPCs, so won't talk about them. But high agency people just usually always trying to like whatever high agency means, right? Like trying to build stuff, trying to get things out the door, like constantly. Yeah, just like being a hustler. Yeah, so that's the new law we've introduced in this lesson. I guess we'll discuss it in where you guys stand in the next lesson. Yeah, but be high agency or be a high agency NPC. Yeah. So next lesson we'll discuss more of the agents specifically, maybe cover a bit of Notion, maybe Proxima. Yeah. So I think that's it for now. Any questions before we conclude?
Any questions? That was a very nice session, Dawn. Thank you so much. Yeah, feel free to show us how Proxima works. Be a shameless plug over here. We love founders. So thank you so much for that. And by the way, before you get shocked, whether you're a founder, an untechnical or technical founder, we are dragging you through the mud this and next week. You're going to learn how to deploy smart contracts. You're also going to learn how to, very soon, towards the end of the week, you're going to need to have a GitHub account if you're an untechnical founder as well. just so you kind of understand how things work, get your hands dirty, and yeah, so get ready to find out what coding agents are tomorrow and how you can use them to ship products, right? Right, Don?
Yeah,
Right?
yeah, definitely. Yeah, yeah.
All right. Thank you so much, guys. Have a lovely evening.
Wait,
Let's see each
Washuka.
other tomorrow. Yes. Sorry.
Don't show the last page, please. I want to take a picture.
Okay.
Okay,
Yeah,
for the
sure.
homework. Perfect.
Which one? Let's see. This one?
Yes. Thanks.
I'd like the other one, the one that has the question. Yeah.
Okay.
Don, there's another one that had
Thank you, Don.
that one.
Which one exactly? This
The
one.
Mimas, the one for the next one.
This one.
No, the one for NPC.
This one. Yeah.
This is what we're supposed to discuss tomorrow. All right, then if there's no further questions, I guess we can call it
I had
night.
a quick question.
Okay.
For Don, what framework do you use when creating a prompt? Like, do you give it a persona, or what do you do?
Yeah, so I think at this point, or like where we've reached, a lot of these agents already have like a pretty good idea when you like give them a task. And a lot of the prompt engineering is kind of handled at the harness level. So that would maybe the coding agent you're using already has the abilities to like there's something called sub-agents, I think we'll discuss later. But so for the most part, me specifically, I don't like I'm not that much of a prompt engineer, like defining stuff like you are X, you're supposed to behave in this way. For me, it's just I just tell it what it needs to do. Yeah, I don't really specify that because I think the models at this point are a lot smarter than they were before, so they're able to know what specifics they need to do in order to achieve the task. Yeah.
Okay, thank you.
Any other question? Don't cut anyone short. Going once, twice. Okay, that's it for tonight. See you guys tomorrow. Make sure you go through the discussion point. So yeah, have a lovely night. Bye.